Good morning, Doctor and everyone. We are from Group 9 and our group members are Chua Jun, Wu Yong Kang, Lai Yan Chi, Chet Chi Him and me, Ng Pizen. So today we are going to present our project for business idea generation and pitching. Our project is called AI Power Smart Parking System. So in this presentation, we will introduce our selected service and explain our design thinking process. So let's begin our product and service selection. For our product and service selection, we focus on the university parking service. The existing service is the conventional university parking service, which is the current parking system used on campus. As an improvement, our group selected an AI-powered smart parking system as our proposed service. It is a digital smart campus service designed for university parking areas. The primary target users are university students who drive or ride to the campus. There are three main reasons why we selected this service. First, it is related to campus life. Parking is directly connected to daily university campus activity. Second, it is suitable for a smart campus concept. It allows us to explore how digital service can be used to improve campus management. Third, it has a clear service direction. The service is easy to identify and understand, and is also suitable for further customer experience analysis. Next, we will move on to the empathizing approach.
Next, I will explain our empathizing approach to university campus parking. At this stage, our objective was not to immediately propose a solution. Instead, we wanted to understand the real parking experiences, frustrations, and needs of university students who drive or ride to campus. We used three main methods. First, we conducted direct observations at UTM Kuala Lumpur during peak hours. We focused on parking availability, traffic congestion, illegal parking, and the time drivers spend searching for a parking space. Second, we used an online survey to collect feedback from a larger number of campus users. The survey covered parking availability, preferred parking locations, searching time, and overall satisfaction. Third, we reviewed parking-related discussions and complaints on university social media platforms and group chats. Though these methods, we explored several key questions. How difficult is it to find parking? When is the problem most serious? What causes the most frustration? And what could make the experience more convenient? Overall, this empathizing approach helps us understand the problem from the user's perspective instead of making assumptions about what they need.
For our observation method, we conducted two 20-minute observation sessions at the main parking areas of UTM Kuala Lumpur on 21 August 2026. The observations were carried out during two different periods, the 7:30 am and the 1 p.m. This allowed us to observe parking conditions during different peak periods. So during the sessions, we observed a total of 20 arriving vehicles. We focused on several behaviors, including parking space, searching, waiting, repeated cycling, and unauthorized parking. So from our observations, we identified several key findings. First, parking availability was limited, with most parking space occupied during the observed periods. Second, 6 vehicles made more than one round around the parking area before successfully finding a parking space. This indicates that drivers often need to spend additional time searching for available spaces. Third, 5 vehicles were observed waiting or moving slowly near the parking entrance, which contributed to temporary congestion in the area. We also observed 10 vehicles using non-designated parking areas, suggesting the limited parking availability may encourage some drivers to park in unauthorized locations. In addition, the searching time for 7 sampled vehicles ranged from 10 to 15 minutes, showing that finding a parking space can take a significant amount of time. So next, we use AI-assisted social media listening to understand students' experience and complaints about parking. For this part, the ChatGPT assisted us in identifying, filtering, and categorizing the public parking-related complaints into several terms and themes, such as parking availability, searching time, and illegal or unauthorized parking. So from Facebook, we found a parking-related complaint from the Thai UMT, DSA Activities and Sport Division. So the post highlights concern about students having difficulty finding parking and suggests that parking availability is a problem in certain areas of the campus. And we also found the content from TikTok showing a vehicle parked on a non-designated area. This provides another example of how limited parking availability may lead to students using inappropriate parking spaces. So overall, this social media finds provide the real-world evidence of parking problems experienced or discussed by students and the campus community. And here, being the part of the AI-assisted social media listening, we also actually focus specifically on parking availability and searching time as well, as shown in this slide. So on the left, we found a post from the Multimedia University highlighting complaints about the lack of parking spaces. The comments also mentioned that there are not enough parking spaces allocated for students, while some parking areas are reserved for staff. On the right, we found comments from students discussing similar issue. One student mentioned the needing to arrive earlier just to find parking space, while others described having to spend a significant amount of time searching for parking. So this comment suggests the limited parking availability is not only an issue at UTM, but also experienced by students at other universities as well. So to conclude, our AI-assisted social media listening shows that parking shortage are a common issue across many cities. Students often have to spend a long time searching for parking or resort to parking in unauthorized areas. This can lead to stress, lateness, and potential safety concerns. Although universities provide official notice reminding students not to park illegally and suggesting alternative parking areas, the complaints suggest that the existing parking capacity may not be enough to meet the growing demand. Overall, this widespread complaints shows that the limited campus parking is a recurrently problem that requires better and more sustainable long-term solutions.
Next, we conducted an online survey to better understand students' actual parking experience. We collected 52 responses in total, and 36 student car or motorcycle users were included in our parking analysis. The findings show that parking is not only an availability problem, but also affects students' time and experience. 75% of respondents usually spend more than 10 minutes researching for parking, while 72 said they have been late at least sometimes because they could not find a parking space. We also found that 67 rate their parking stress or frustration at 4 or 5 out of 5. Most importantly, 81% rate advanced parking availability information as useful. This tells us that students do not only need more parking space, they also need better information before they arrive. When their preferred parking area is full, many students wait for a space, park further away, or continue circling. Some even resort to unauthorized parking. So overall, the survey confirmed that searching time, lateness, and uncertainty are major pain points for students, drivers, and riders. Based on these survey findings, we analyzed the overall customer experience. First, the main problem encountered are long and repeat search for parking, together with difficult finding an available space. This problem creates several inconveniences such as waiting, circling around the parking area, moving to another location, walking longer distance, and wasting both time and fuel. We also identify several unfulfilled requirements. Students want to know parking availability before arriving, how many spaces are available, where those spaces are located, and which parking area is suitable for their vehicle. The high level of stress and lateness also show clear dissatisfaction with the current parking experience. Therefore, our defined statement is that students, drivers, and riders need reliable parking information before arrival to reduce unnecessary searching, lateness, and stress. This leads us to our how might we question. How might we help students, drivers, and riders anticipate suitable parking before arrival while reducing search time, lateness, and frustration? And this question becomes the foundation of our proposed solution. Based on these identified needs, we then moved into the ideal stage to develop our AI-powered smart parking solution.
Now, based on our empathy research, we identified several major problems faced by university students. Students struggle to find available parking. There's no real-time information about parking spaces, and they often waste a lot of time searching. This also causes congestion and can lead to illegal parking. To solve these problems, we propose our AI-powered smart parking system. Our system provides a more convenient and satisfying parking experience through several features. For example, users can check parking availability through a digital display or mobile apps, while sensors detect whether each parking bay is occupied or available in real time. The system can also use AI to predict the best time to arrive based on our historical parking data, class schedules, and campus events. The app can then recommend the nearest available parking zone and guide users directly to an open space. In addition, users can receive notification when a parking slot becomes available, and the system can provide real-time alerts to reduce illegal parking. Our unique selling proposition is that our system combines live IoT parking detection, AI demand prediction, and vehicle-specific guidance before users arrive. Unlike traditional static parking signs or booking-only applications, our system not only tells users what is available now, but also predict what is likely to be available when they arrive. The technology works in four main steps. First, IoT parking sensors collect real-time occupancy data. Second, this current data is combined with historical parking information. Third, AI analysis factors such as time, days, class schedules, and campus events to predict parking demand and availability. Finally, the mobile applications recommends a suitable parking zone and the best arrival time for the users. With this parking system, we expect to create several positive impacts. First, it can reduce the amount of time students spend searching for parking. Second, it can reduce traffic congestion and discourage illegal parking, making the campus safer and more organized. Third, by using parking data, the university can better understand parking demands and make better decisions about future parking capacity. Most importantly, our solution addresses a common problem faced by many universities. Parking shortage can cause stress, lateness, and safety issues, so a smarter and more efficient parking system can significantly improve the overall campus experience. This solution also supports the sustainable development goals, especially through smarter resource management, better urban mobility, and the development of a more sustainable and efficient campus environment. Overall, our AI-powered smart parking system transforms parking from a stressful searching process into a smarter, faster, and more convenient experience. Thank you.